In exercise 7C, we start to look at the financial aspect of a GP. So we're going to set up originally a sequence. We will realise that it becomes a series because it's an investment, so we're adding together amounts. Then we're going to look at what part of this series we've got is actually a GP. It's a little bit like one of the examples we did in class and found that not the whole series is a GP. So we take bits out, we separate it, and we identify just the part of the series that behaves like a GP. And once we've done that, we can use the summing a GP in order to calculate the value of this investment. So this investment that we talk about is called an annuity, more commonly called an annuity. An example of an annuity is superannuation. I'm not sure how familiar you are with that, but what super, and I'll just call it super from here on. What super is, it is a system whereby you deposit small amounts on a regular basis into an account and leave it there for an extended length of time. So you can imagine if you're depositing, and I'm just going to jump to a Word document. So if I'm depositing, for example, say P dollars, and what I know is that P dollars is going to sit there for years and years and be compounded monthly, and in the end that P dollars is going to be worth significantly more. And that all depends, how big it actually gets depends on the interest rate and how long I leave it there. A short time after that, I'm going to deposit another exactly the same size P amount. Now, it's going to sit there and be compounded, and it's going to earn interest, and it's going to grow, but because it's not sat there as long as my first deposit, it will be slightly smaller. Then, after a short amount of time, I deposit another exactly the same amount. It's going to sit there earning interest, but it doesn't sit there as long as the second one or the first one, and it's going to grow into P dollars. Well, this continues on over many, many years. You do have to be careful because in some situations, the last amount, you could have this option where it earns interest and gets a little bit bigger, or the last payment is made and collected at the same time, no interest is earned on it. The way you'll know that is in the wording of the question. If they say it's deposited at the beginning of a year and we're leaving it there for the whole year, then obviously it's this situation was deposited. Or if it says it's deposited at the end of the year and we're finalising our investment at the end of the year, then a deposit goes in, but it doesn't have any time to earn interest. Hopefully you can see from that bit of a diagram that we would actually, if we want to know the amount of our total investment, then we want to sum all of these P's Now, within there, we're hoping we'll be able to establish a GP. Now, the whole thing won't be a GP, but within it, there'll be a GP. So you'll have big first instalment, a little bit smaller, and this is going on and on and on, and we're summing up all of these, and that would equal our total investment. Okay, I'll go back to the notes now. Let's have a look at this example. Casey's grandparents invested $1,000 in an annuity for him on the day he was born. They continued to invest this $1,000. Remember back in my diagram, they were little money bags with the original P. On his birthday each year thereafter until he was 20. So they deposited until he was 20. On his 21st birthday, they gave him the final amount in the investment. So they didn't deposit another amount on his 21st birthday. They stopped when he turned 20, but collected it a year later. So you can see that the last amount does earn some interest. Calculate the amount Casey receives on his 21st birthday if the annuity earned 7% per annum compounded annually. So that's fairly easy, compounded annually. We don't have to make any adjustment to the rate. So yeah, just makes it slightly easier. It's important that you can identify the number of terms. So remember, they invested $1,000 on the day he was born. So then when he's turned 1, a second deposit goes in. When he turns 2, a third deposit has gone in. So when he turns 20, we're up to 21 installments altogether. So hopefully you can see, just using A is P 1 plus R to the n, the compounding period formula, the compounding interest formula. $1,000 is being invested, 0.7%, nothing difficult about that, for 21 periods or 21 years. However, the second instalment will only sit there for 20 years. Still $1,000, still the same rate, sitting there for 20 years. The third instalment sits there for 19 years and amounts to 1,000 times, I'm going to write it as 1.07, you'll see that, to the 19. And so on. The 20th installment is invested for 2 years. It's just one less, so and amounts to 1,000 times 1.07 to the sitting there for 2 years, and the very last one is invested for 1 full year and amounts to 1,000, 1.07 to the 1. Now, the total amount invested is obviously the sum of, and there are some amounts missing in here, the sum of these 21 amounts. Now, what you see that I do in the next line is actually reverse the order of the instalments. So I'm saying the total amount invested would be the last, this is the very last one, it's invested, it's only going to sit there for 1 year. So 1.07 to the 1 is 1.07. The second last instalment sits there for 2 years. And so on and so on, and we know that the very first one is this one, and it amounts to that. Now, we can think of this in two ways, and just to keep the numbers small, I like to think of it as just factorising it for now, because we can see within every term there's $1,000. So it's 1.07 plus, now take it out, 1,000 out of this, we've got 1.07 squared. We'd have 1.07 cubed up to 1.07 to the 21. So we've actually got 21 terms here, and this becomes a GP with A has 1.07, R, this term over that one, would be 1.07. Just double checking. This over that, 1.07. And N is 21. So this sum is, this total amount invested is coming out rather nicely. We've got, if we can work out the sum of this GP, which we do using this formula, then multiply that by 1,000, we've got the total amount invested. So you can see now I've substituted into the formula just using the values that I had identified in the line above, and going to the calculator, and please use the fraction button on your calculator, and you can see that's 48 point, I'll write it to 4 decimal places. In hindsight, I thought I should go a little bit further. So you can see I've written out all the decimal places. Then the total that would be invested is the 1,000 times the sum, and 1,000 times that, move your decimal point 3 places, $48,005.39. Now, that would be a reasonable answer. If I think about how much was deposited, there were 21 deposits, because 21 installations, 21 deposits, at $1,000 each. So you can see that $21,000 has been deposited over the course of the time in total. And yes, that's a very nice investment, isn't it? You've over doubled the money. Yeah, so that's a very worthwhile investment. So I'd be very happy with that, 48,000. It says just again this concept of whether we get to the end and the deposit does earn interest or doesn't is all tied up in the wording of the question, and it's just something that you need to be aware of. So you'll need to read questions very carefully for that.